Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, Ricardo Lopes, and today I'm joined by Dr. Nathan Lents. He's professor of biology at John Jay College in the US. He is noted for his work in cell biology, genetics, and forensic science, as well as his popular science writing and blogging on the evolution of human biology and behavior. He is the author of books like Not So Different, Finding Human Nature in Animals, and the book we're going to focus on today, Human Errors, a Panorama of Our Glitches from Pointless Bones to Broken Genes. So, Dr. Lentz, thank you a lot for taking the time to come on the show. It's a pleasure to have you on.
It's my pleasure to be here.
Okay, great. So it's interesting that you call some of these traits that you go through in the book errors. So, from an evolutionary perspective, why would these be errors? And I don't know if you already want to give some examples in your answer or not, but is it are they errors because they interfere in the evolution of a particular organism, in this case humans, or is it that they simply bring some problems to us during our lifetimes?
Well, it can actually be both of those, or either of those. I call these errors or clicks or quirks or flaws or glitches. I use these words somewhat provocatively, in the sense of not all of them may turn out to be flaws the way we understand flaws. Some of them have advantages that are worth whatever disadvantages they bring. Others of them are not. They're just really just bad luck. But I call them errors on purpose to sort of uh, jostle people out of the notion that biology is perfect and that organisms are perfect or that humans are perfect. There's a common misconception that all living things are more or less perfectly suited for their environment. They're perfectly suited to do what they do, and that and if you were to answer a multiple choice question, are organisms perfect for their environment? No one would say yes, but we still have the bias. We think of them as perfect. And so a lot of the flaws and glitches that I point out in my book were quite surprising to people because they sort of expected us to be better than that. They expected our bodies to work better than that. And they don't. And the real lesson here, and the reason why I wrote the book, is to try to dissuade people of the notion that evolution produces anything like perfection. Evolution makes us sort of just good enough. In fact, I've heard it put this way. I can't remember where I first heard this, but it's not survival of the fittest, it's survival of the fit enough. One common joke that's used is when the two people are in the woods and a bear starts chasing them, and one of them says, well, we're not going to outrun this bear. We're not fast enough. We just have to give up. And the other person says, I don't need to be faster than the bear. I just need to be faster than you. And that's kind of how evolution works. It's really just who can stumble through and leave some offspring. So that's the first misconception that my book is written against, is this idea of perfection. The second misconception that I'm writing my book against is that humans are in any way the pinnacle of evolution or the pinnacle of creation, or the most perfect organism. Once again, we might not get this wrong on a multiple choice test, but a lot of people sort of think of evolution as this steady march of increasing complexity, increasing sophistication, eventually leading to us. And that's just simply not the case. First of all, evolution doesn't always favor sophistication. Sometimes it favors simplicity and speed and efficiency, which are the opposite in many ways of sophistication. And also, there are organisms that are better at almost everything humans do. There are organisms that can run faster. There are organisms with better immune systems. There are organisms with a more efficient heart. Almost every part of our body has some inefficiencies and quirks and glitches. The only thing that we do better than anyone else is computation and some cognitive functions. And really, that's about it. And so the most revealing parts of this book are that when I show how other animals really function better than us at the molecular level and cellular level. And it doesn't mean that humans are terrible or ugly or gross or non-functional. What it means is that humans have been living through our ingenuity and our social cooperation much more than the prowess of our bodies. We're allowed to have bodies that aren't that fast and that get sick because we take care of each other. And we invent medicine, for example. So we use our big brains and our sociality and our division of labor to compensate for the fact that our bodies really just aren't that great.
So these errors that you talk about in the book, and we're going to run through some examples later on in the interview, do they occur more frequently in humans than in other species, or is it roughly the same?
So it's very hard to put numbers on anything like this. So I'm going to make a very unscientific statement here, but I will say that yes, humans are probably more flawed than almost any other creature. We have more of these quirks and glitches than most other creatures. And the reason I can say that with confidence is that we have figured out so many ways around those flaws. And what that means is that we've taken evolutionary pressure off of natural selection to fix these flaws. Most other creatures live and die by how good their bodies work. And that's just not true for us. I mean, and if you think about, I've used my own body as an example. My vision naturally is horrific. I need very strong corrective lenses in order to survive. And that's true of a lot of people. But imagine an eagle who had bad eyesight, or a hawk. Right? They would die and they would take their bad eyes with them. And so for that reason, you almost never encounter any birds of prey with poor vision. So genetically, they have completely shaped their visual system to be as good as it can be in every single individual. And that's just not true for us. The reason why is if you have bad eyesight, it generally doesn't kill you. You just do something else. There are certain jobs you might not be able to do, and that was true way back in hunter-gatherer days. Maybe you wouldn't be a very good hunter, but hunting is just one thing that hunter and gatherers do. You could have been a forager, you could have been a homesteader, you could have worked with your hands, you could have helped with child rearing, you could have been smart, you could have had idea. There was just so many ways that you can contribute. And that's really getting at the unique features of humanity in that we are the ultimate generalists. There's so many different things we can do. Other species can run faster, jump higher, are stronger, swim better. But we can do all of those things. And very few species can do as many things as we can, both physically and mentally. But what that means is there's many ways for you can contribute. And it takes the evolutionary pressure off of you to be perfect. So ultimately, it is a book about human flaws, but it's not a sad story. It's a happy story. It means that, aren't you glad that you don't have to be perfect? Aren't you glad that if something fails, you have other things to rely on, including your fellow humans? And I should say, especially our fellow humans. That's really the answer to everything in human biology, is the fact that we work together.
Mm-hmm. Are all of these traits, or at least some of them, adaptations? I mean, is it the case that some of them have been selected for by natural selection, or is it simply traits that evolution by natural selection, for one reason or another, hasn't been able to weed out?
That's a great question, and the answer is both. So there are some examples of things that we have adapted into that therefore we sort of evolve these glitches on purpose. I'll give you some examples. So for example, we have enormous advantages by walking upright versus walking in a hunched over, largely quadrupedal way. So if you watch how a chimpanzee or a gorilla moves around, we straightened our back. But in order to do that, to accommodate everything that we needed to, particularly with childbirth, we couldn't straighten our backbone. Chimpanzees have a more J shape to their backbone, like our ancestors did. But we couldn't just straighten that out. What we had to do was add a second curve. So our backbone has an S shape to it rather than a J shape to it. And what that creates is a point of weakness in the lower back where you have the sharpest curve. And that is where you can get a slip disc. That's where you can get lower back pain and muscle strain. And so it was undoubtedly a good thing that we started to walk upright. It freed our hands. It allowed us to see over the brush. No one questions that walking upright gave us enormous advantages. However, it also brought some disadvantages. And you find those disadvantages in our knees, in our back, in our ankles, in our Achilles tendon. We have several vulnerabilities that other apes don't have. For example, a slip disc that I just mentioned, a herniated disc in medical terms. Those are unheard of in other apes. You will never find a chimpanzee or a gorilla with a slip disc, but you find humans with them all the time. So those are what we call evolutionary trade-offs. Evolution can only work with our bodies as they are and make the tiniest tweaks and tugs. It can't invent whole new physiology or whole new anatomy. And even when it does do that, it takes a very, very long time, and it does so with incremental steps along the way. So some of the flaws that I write in the book are the result of evolution. They're adaptations that had downsides to them. But overall, we would say they were positive. Other flaws that we have brought no benefit whatsoever. They're just pure bad luck. Example I use of that is we have what are called pseudogenes. So these are genes in our genome that are no longer functioning. They've been mutated beyond repair. They don't express anything. They don't do anything. They're pure junk. These are called pseudogenes, false genes. They look like genes. It's kind of like a car. If you go to a junkyard and you see a car, it looks like a car. You can tell it's a car, but it's missing some key parts, so it will never function as a car. And in fact, it would be very hard to resurrect it as a car, right? So it's there, but it's non-functional. We have some of those in our genome. Many of them have no consequence. They're just extra copies. But some of them, man, I bet we wish we had them. And the most famous one for this is called the gulo gene, and this is necessary for vitamin C synthesis. So most animals out there make their own vitamin C. They don't need to incorporate it in their diet. They just have it. It's made in their liver, and this is one of the genes that's necessary for that. But our gene has been mutated beyond repair. We have that gene. It's there. We can find it. We can study it, but it doesn't function. It doesn't do anything. And therefore, we must consume vitamin C in our diet, or else we'll die. Scurvy, which is the condition of vitamin C deficiency, is ultimately lethal if you don't do anything about it, if you don't find some vitamin C. And what that has done for, 100 million years or so, is restrict where primates can live. Primates cannot just live anywhere in the world. They can only live where they can find vitamin C, enough vitamin C to survive. And if they don't, they would get scurvy and die. So there's nothing gained by the loss of this gene. There's no trade-off. This is not just an adaptation. It got mutated, unfortunately, and it didn't have a cost immediately, probably because, certainly because the individuals that suffered the original mutation were living in an environment rich in vitamin C, like the rainforest, like our ancestors lived in. And so there was no consequence. But it then had ultimately tons of negative consequences down the road. And the lesson there is that evolution doesn't think ahead. Evolution doesn't have any plan or direction to it. It just happens, and then you can fall into a state of very bad luck. I'll give you one more example of a pseudogene. There's a protein called theta defensin, which many other apes, most of the other primates all have. And this gene it creates a protein in the immune system that's very good at stopping certain retroviruses from causing an infection. And retroviruses include HIV, the human immunodeficiency virus. Well, if we had theta defensin, it's very reasonable to think that we would never have had the HIV epidemic that we had that killed and continues to kill so many individuals. Theta defensin might have protected us. So this was a pseudogene, and it weakened our immune system when we suffered those mutations. Nothing gained, simply bad luck.
I understand. Are these errors genetically encoded, or does development also play a role here?
So the ones I talk about in the book are genetically encoded, and they take shape through the process of development. That doesn't mean that we're completely tied to them. And there are a few that are not the result of genetics, and I'll give you an example of that in just one second. But the vast majority of what I cover in my book has to do with genes and physiology that is encoded, that no matter how we were brought up, we would have these flaws. There's nothing you can do, for example, about your weak little ACL, that ligament that holds your upper leg and lower leg together behind your kneecap. It is tiny, it's small, it is not big enough or strong enough for the job that it has to do in our species. But there's literally nothing you can do about it. You cannot work it out to strengthen it. You can't stretch it to make it stronger. Literally nothing you can do. And as our bodies get bigger and we play professional sports, it snaps all the time. Believe me, sports medicine would love to figure out how to make it stronger, but we can't. There's one thing you can do for the ACL, and that is surgical repair. That's really the only tool we have. So there's nothing you can do about that. But here's something you can do with your physiology. Well, there's a lot in the diet chapter that you can do, actually, once we realize how needy and strange our diet is, we can actually accommodate that. So we can eat foods that keep us healthier. But here's a great example. So I gave you I mentioned the fact that I have very poor vision on my own. I actually don't anymore. I had it surgically corrected. So that's a perfect example of how cultural evolution can compensate for limitations. Anyway, about 40% of the population in Europe and North America has myopia, which is the inability to see well at distance. So that's the kind of glasses. If you get glasses early in life, that's what you have, myopia. 40%. It's something like 75% in East Asia. So most of the humans walking the planet have poor eyesight, but this was not always the case. And in fact, we now understand that this is a problem with how we live, not so much a problem with our bodies. And the way we know this is that individuals who spent the majority of their childhood outdoors don't suffer from myopia to near the same degree. But if you spend the majority of your childhood indoors, you are much more likely to need glasses as an adult. And the reason why is as our eyeballs are still growing, and they are growing through childhood, they grow too long if you don't spend a lot of your time looking at distance. If you're indoors, you're trapped inside. And remember, that's what we do now. They go to school, they go to daycare. Most of the winter in the northern latitudes, we're inside. And so our children grow up to need glasses because their eyeballs are just not used to seeing at distance for enough hours a day. But that's something we can fix. So get your kids outdoors. A lot of people are like, well, eyeglasses were not invented until the Middle Ages in Europe. So did people just walk around with terrible vision? And the answer is no, they didn't. Before the Middle Ages, we did spend the majority of our life out of doors. And so glasses were invented when indoors was invented, so to speak. So as soon as we really needed them, that's when they were invented. Humans are good at that. We invent things when we need them. And so prior to the Middle Ages, we didn't spend the majority of our time indoors. And so that's why our vision's that way. So that's a good example of how the way we live has caused these problems. And the good news for that is that there's something we can do about it. And there's an invention now it's going through FDA approval. There's clinical trials for glasses that children can wear that spreads the light out to make it seem as if things are farther away, and their eyes have to work harder to focus them, and it's as if they're looking at distance. And the clinical studies are designed to see if this prevents myopia. Most people think that it will, so we'll have to see.
Mm-hmm. Could it be that some of these errors persist or are even created by things like modern medicine because it extends our lifespan? And I mean, perhaps one example that comes easily to mind is cancer.
So okay, there's a couple of separate issues. Let's take the cancer issue first of all. Okay. One thing that's clear is that we will all get cancer if we live long enough. if you continue to live free of infectious diseases and injuries and heart disease, you will eventually get cancer. There's just simply no way to avoid it forever. Every time a cell in your body divides, one cell splits into two, that's a chance for you to get cancer. It's a roll of the dice. And so you can't beat the odds forever. Everyone will eventually get cancer. And so when you understand that, you can start to see the majority of the increase in cancer rates in the world is simply because we're not dying of other things. If you look at the statistics from even the early part of the 1900s, what we died of was polio and cholera and generally diarrheal diseases and those are almost all gone. So tuberculosis, almost all of the things that even accidents and so forth, most of the things that killed us 100 to 150 years ago don't kill us anymore, which means we live long enough to get cancer. So most of the increase in cancer is just simply that we're not dying of infectious diseases, mostly. However, there is also a little bit of an increase in cancer that doesn't seem to be the result of that. And this is where there's a lot of interesting research. It turns out that when we do approvals for certain pesticides, we'll say, or any kind of food additives and things like that, we look for more acute causes of poisoning and toxicity. What we don't look for is, what if you have a small dose of this over 30 years? Will this cause cancer? And the answer, we don't know what it is, but I am sure that there are many environmental contaminants that are contributing just a little bit of the odds to get cancer. And if you have enough of those around, it will have a measurable effect on the population. That doesn't mean that you can pinpoint it as a cause in any individual, but in the population at large, the increase in cancer rates is partially due, I think, to xenoestrogens and other environmental pollutants and contaminants that we're ingesting in our bodies every day. But I think the vast majority of cancer causes is just bad luck, and we're living long enough to get it. Mm-hmm. But cancer is just one example. Let me return to your question, because it's a very good question. Is modern medicine causing us to get certain diseases and things like this? For the vast majority, no. But what we are doing is that we're not dying of things, and therefore we're passing them on genetically. This causes me no ill will or angst, because I'm certainly glad that having a genetic disease doesn't mean that you are poisoned to the gene pool. Our ability to fix those diseases is a testament to our greatness. And does it mean that we'll have some more deleterious genes in the genome for a little while? Possibly, but we're learning how to correct those too. So most simple genetic diseases, we're going to be able to correct those. That's within a couple of decades of technological development. Sickle cell anemia, hemophilia, cystic fibrosis, genes that are caused by one or two mutations, a single gene or two genes. We're going to be able to fix those, and we're going to be better as a species for doing that. However, sometimes it's asked, well, but aren't we in general just keeping sickly genes in the population for longer? This causes me a lot of concern that people even think this way, because you have to remember that what's sickly and what's good or bad for the population changes every generation anyway. So the idea that we have some genetic undesirables in our mind right now, that no one cared about that 2 generations ago, no one will care about that 2 generations from now. So I think I wish people would stop thinking of natural selection as our friend to weed out undesirables from the population. What is desirable and undesirable is a moving target anyway, and largely the result of our own prejudices more than anything else.
Mm-hmm. By studying these errors, can we get a better understanding of the evolutionary pressures that were operating in this case on humans?
I think that's exactly the value of understanding our errors and flaws. That's one thing when I talked about why someone should read the book. We think of dissecting our past using fossils and trying to figure out our evolutionary past from fossils or archaeology, artifacts. That's a great way to do it. It's an irreplaceable way to do it. We can now look at our past using DNA sequences, and that's a great way to do it. But what I argue in the book is that we can actually look at our bodies as they are right now, and we can find hints of our evolutionary past. And when you understand how we became this way, how we became the way that we are, you start to figure out ways that you can live in better harmony with your body, better harmony with your mind even. By understanding the forces that shaped you, you can stop fighting those forces, for example. And, it's simple things like, for example, stop sitting in chairs so much. That's a very simple thing you can do, is get yourself a stand-up desk and get used to that a little bit, and try to get exercise more regularly rather than saving up for 2 big runs a week or something like that. Maybe just go on a walk once or twice a day. Little things. But there's also big things, like changing what you eat. We have such a big carbohydrate-based diet. And what we now know is that this was never good for us. This was never good for us. It allowed us to generate a lot of food and therefore swell the population. But we have been sick ever since we switched to a carbohydrate-based diet. All cultures everywhere around the world, their main staples are all carbohydrate-based. And that's just not how our ancestors ate for millions and millions of years. It's really an artifact of farming and agriculture. But that's harder to do, right? Because food, low carb, but still nourishing food is generally more expensive. It's harder to come by. There's a reason why crops were so successful, right? They're cheap and easy to grow in large quantities. We can feed the masses, but we can't make them healthy on carbohydrates. So we have to think about making tougher choices there, and also just in the way that we interact with one another. So we have a lot of in-group biases where we tend to identify with those that look like us and that speak our language. We call that they're predictable. So people who are like us are predictable, which means that they cause us less psychological distress in interaction with them. However, the downside of in-group identification is xenophobia and racism, and they're a natural consequence of the way that we evolved. We are evolved to find a group and identify with that group at the exclusion of other groups. So people ask me, are we evolved to be racist? And the answer is yes, but that's not permanent. It's not inevitable. There are things that we can do, which is basically just to expand our definition of in-group. And the way you do that is by cross-group contact, especially in childhood. So whatever race or nationality you are, if you can expose your children to other kinds of people all throughout their childhood and have them form friendships with people of other races and nationalities, that helps to prevent that strong in-group identification and instead breeds out-group identification, or I like to think of it as an expanding circle of in-group identification, with the ultimate goal being is that we're all in the same group, the entire planet. If we think of ourselves as in the same group, then we can trick our psychology into a more harmonious social life. And the thing is we're so globalized now that that's the truth anyway, right? We are dependent on one another. We all affect one another, and we live together on this planet. And if we don't really, figure out how to do that better, dark days are ahead.
Yeah. Looking at the modern state of the art of evolutionary biology, is it possible for us to make some predictions about how we will evolve in the future? And if not, do you think that somewhere in the future we will be able to do that?
So people ask me all the time, are we evolving? What does the future of evolution hold? And the short answer is we don't know. It's unknowable. It's very hard to know. But I can talk for a little bit about it anyway. So one thing is clear is we are evolving, because anytime you have non-random reproduction, which we definitely have on this planet, we are evolving. For example, Italians and Japanese have very low birth rates. But yet in countries like Somalia, Afghanistan, there are examples in almost every continent of countries that have very high birth rates. So whatever it is about their genes is going to be more represented in the next generation, and so on. And that will change. The birth rate situation was different a generation ago, a generation before that. So no one knows how those will change going forward. But we do know that there's a differential contribution to the gene pool. What can we take from that? Well, one thing that we're doing now is we're very, very close to being able to fix certain genetic diseases. And I think that will start to become incorporated as a normal part. In 100 years from now, rather than doing genetic screening to sort of prevent pregnancies that are unwanted or undesirable, we'll just simply fix them. And I think it will be that easy. So rather than having a child with cystic fibrosis, you have a child who's well, actually, probably you would prevent that from happening in the first place by fixing it in the parents, because it's inherited. So we can fix those things, and I think we will. We're also going to start living more closely with technology, and the embedding of technology into our biology, we're on the cusp of that as well. Like I said, I had surgical correction on my eyeballs. It's not hard to think about more sort of implants, more sort of permanent technology embedded in us. And I think that we'll go that route as well. I don't see that as necessarily harmful, although it may have unnecessary consequences. But other than that, it's hard to say how we're going to evolve. Cultural evolution is so much more powerful than biological evolution at this moment, that it more depends on decisions we make on how to live rather than it does on our genes or our biology.
Mm-hmm. So let's now run through some examples that we haven't yet touched on during our conversation. About our genome. So there are non-functional genes, we have viral DNA, there's self-copying DNA. Could you tell us a little bit about those kinds of errors?
Right. So our genomes, frankly, are a bit of a mess. And I'm a genome scientist. My research is looking at the human genome very carefully and looking for functional islands amidst all of the sea of noise and gibberish. So yeah, we have the remnants of previous viral infections that our ancestors fought, but the virus left its carcass in our DNA, and we still copy it and pass it on to our children, and it does nothing for us, at least nothing good. We have parasitic DNA, little stretches of DNA that are very good at copying themselves, and they even jump out of the DNA and jump back in somewhere else. Some of them are very prolific. We have millions of copies of some of those selfish DNA elements. And they do have negative consequences. I mean, millions and millions of individuals have died, because this crashed into an important gene, and we'd have no way of knowing that until very, very recently. But also occasionally something good happens. So, for example, primates, and not all primates, but a branch of primates has what is called trichromatic vision. So we have 3 different color receptors in our eyes, which gives us a much richer palette of color detection than other mammals. So dogs and cats have dichromatic. So they're not colorblind, but they don't see colors as well as we do. They only have 2 color detectors, and we have 3. So we can cover more of the spectrum with more resolution. Well, the way that happened is a selfish DNA element crashed into the genome very near one of the genes for one of those photoreceptors and copied it and then placed it somewhere else. And so we got a duplicated version. And then once you have 2 copies of something, evolution loves this. It's fantastic because you're free to tinker around. Usually if you have just 1 copy of something and you tinker with it, it's bad because it's much easier to harm something by random tinkering than it is to enhance it. But once you have 2, then it's fine because one version can withhold the normal function of the gene. And then the second copy is free to tinker around and explore. And it doesn't matter if the negative mutations hit it because you've got the other one as a backup. And so things like trichromatic vision and other things have evolved because of this copying by selfish DNA elements. So while from person to person, this parasitic DNA that we carry around in us is generally bad. It's much more likely to harm you than help you. But over the course of evolutionary time, it's excellent. It's really powerful tool. It's innovative. So it's good for the species, but bad for the individuals is one way to think of it, because it allows us new functionality, but at great cost along the way. So yeah, one statistic I think is most people are surprised by is that 9% of our DNA is viral in origin. 9%. And remember, only 3% of our DNA are, functional genes that code for something. That doesn't mean 97% does nothing, but only 3% really code for any specific molecule. So you have 3 times more viral genes than human genes is one way to think of it. And most of that, I would say all of it, does nothing good for us, and it's mostly bad. And that's one of the errors. But again, an error, whether or not it's a good thing or bad thing, just depends on your point of view and your context for timing. So right now, it can harm you. But over the course of 50 million years, it can lead to new innovations for the species.
Mm-hmm. Let's talk now a little bit about our reproduction and some errors that we find there. So, for example, could you tell us about the problem with our fertility rates and also mortality rates for mothers and infants?
Yeah. So we have one of the least efficient reproductive systems of mammals and primates. And that sounds really strange when you consider that we've taken over the planet. There's 8 billion of us almost. But believe me, our rate of infertility is much higher than other primates. And in fact, most of us know someone in our life who has struggled with fertility issues. And those fertility issues run the whole gamut. It can be from the failure to make functional sperm or eggs, or the ability to retain a pregnancy for long. There's all kinds of things that can go wrong. There are a lot of genetic accidents that happen during the fusion of sperm and eggs. Some of those most of those are not human specific, but we seem to be uniquely bad at making more of ourselves. And it's not clear why that is. One thing, we mature later in life. So most other apes are sexually mature much younger than we are, and that makes them more prolific because we have to survive long enough to reproduce. So that's bad. For the species. We also we also have concealed ovulation. So that's kind of funny. Most primates advertise their fertility very obviously with sights and smells and everything else, and it's very clear to all members of the group who is fertile and when. And that's just not true for us. We have concealed ovulation, which is inefficient if the goal is to try to reproduce. However, what it has made us is into a very sexual species. It means that women are receptive to sexual activity throughout their entire menstrual cycle, throughout the entire year, and throughout pregnancy even. And that's a good thing because that sexual activity promotes social cohesion of the group. And if you want to consider the group the nuclear family, most of us live now in nuclear families, but sexual activity is important for bonding in a nuclear family. But much more communal living in our past, and that kind of sexual activity. So concealed ovulation is inefficient for reproduction, but it's really good for social cohesion. So it's one of those, trade-offs. But the biggest problem for us actually is what we call infant incapability. So because our heads are so big and our birth canals are so small, and one of the reasons our birth canals are so small is that we narrowed the bottom of our pelvis. So in order to walk upright, we brought our legs in and straight down. Because that way you can have this nice striding gait where your center of gravity doesn't bounce back and forth very much. That in order to be upright walkers, you really need the narrowing of the bottom of the pelvis. And when we did that, we really cramped the birth canal. And then 2 million years later, the head started to expand. And so something had to give there because you got a bigger head and a smaller birth canal. You're pulling at both ends of the rope there, which is a common evolutionary story, actually, is that you're pulling in two directions at once and you reach some sort of compromise. The compromise that we had to make was that we're born too early. Human infants are born way before they're really ready. They're only half cooked. And in fact, many doctors sort of consider the first 3 months of life as to be the fourth trimester of gestation. We are not fully cooked when we're born. And because of that, our immune system is quite naive. And we're very sickly. What makes all of that worse, of course, is that we live in these huge groups and infectious disease spreads through our population much faster and much more prolifically. So we are sicker than other species too, simply because of our population numbers. But our livestock isn't as sickly as we are. So there's more to it than that. But the result of that is that humans have a very high infant mortality rate until modern medicine kicked in. Modern medicine has largely solved this. The invention of soap helped a lot, but we've solved a lot of infant mortality and maternal mortality too, by the way. Women die in childbirth in our species much higher than they do in other primates or even other mammals, and they all have live births as well. Infant mortality was probably close to 10% for most of the history of our species. And we're defining infant mortality as any death before age 1. So imagine another species where 10%, the children didn't even make it to the first birthday. It's just unheard of. And there are some poor countries where that's about the number now. And it was like that until very recently. I mean, the example I always give is if you think about Abraham Lincoln. Abraham Lincoln, for his time, which is 160 years ago, 170 years ago, had the best healthcare money could buy. He was as privileged as you can be. He had 4 children, and only one of them lived to adulthood. Right. So, I mean, imagine how recently that is and how poor the state of healthcare was at that time. And in fact, the one child that he had very limited progeny and so on, and to the point that he has no direct descendants now. The last direct descendants of Abraham Lincoln died in the 1970s, and there is no direct descendants of Abraham Lincoln, or George Washington for that matter. So we have a weird problems with fertility in our species, where you have very few individuals are very prolific, and most individuals leave no offspring, or very, very far down the line.
Mm-hmm. Because our species has a high maternal mortality rate, wouldn't that be a problem because human infants are so needy, or could it be compensated by things like cooperative breeding?
That's right. So cooperative parenting, it's sometimes called alloparenting. Mm-hmm. I think the field of anthropology is really close to a consensus that prior to agriculture, the human family was much more communal than we think of it now. We think of the human family as a father, a mother, and children. And that's really, aberration might be saying it too strongly, but that's not how the human family was structured for most of our history. That really came into the picture when resources became plentiful so that we could accumulate wealth. And the creation of the family was much more about concentrating wealth and competing with other groups, within the groups with other families. I think communal parenting was the norm, and communal. I mean, the human family would have been basically the tribe, and it's even likely, we think, that we didn't even know whose children were whose, at least in terms of paternity. And while we would have known for maternity, obviously you know who the mother is, but that wouldn't have mattered to the group. It would have been largely women nursed each other's children and fed each other's children. And would they maybe give a little extra to the child they knew was theirs? Yeah, probably. The competition and cooperation always exist together. So there was that. But we now are pretty sure, based on fossil record, archaeology, but also based on looking at hunter-gatherer tribes, so contemporary pre-agricultural civilizations, do not seem so hell-bent on this nuclear family. They're much more cooperative, and if you think about it, it's a much more egalitarian way to live, where all individuals were sort of respected and admired by the group, and didn't really need a family tie in order to have access to their basic needs being met. And in fact, actually, there are cultures now, still today, tribes today, that the idea that a child has a single father, for example, is totally strange to them. In fact, this is getting a little graphic, but there are cultures in which a woman has sex with multiple men, and each one of them is contributing cumulatively to parenthood. So the idea is that you need an influx of this material in order to complete the process of creating a baby. And while we now know biologically it only takes one father, culturally in those systems, the idea that you would have a cumulative fatherhood is really quite beautiful, because it means that the group, it's not really you are the father and not you. It's more of, we're all in this together, and these are the children. These are our future in this group, and it doesn't matter who belongs to whom. We're all in this together, and natural selection will take care of the weeding out of genes and things like that. But communally, we can care for one another, and I think that I'm not advocating the breakup of the nuclear family. I'm married with children myself, but I think there's something to be gained by thinking communally about how we take care of our children. And the thing is we sort of do it already, right? We have public schools, we have daycare, we all kind of cooperate to raise the children. We just have this monetary exchange. Well, what if we forget about the monetary exchange and just sort of did it because it's part of our cultural process? That's basically what happened before agriculture. So I don't remember what question took us down this route, but we were talking about communal parenting. And it does seem that the natural state of humanity is a much more communal arrangement, even for something as intimate as raising children.
Mm-hmm. What about our minds? What are some of the biggest errors we find in our minds? I mean, because we've been focusing a lot on physical and physiological traits, but our minds are also the products of evolution, right?
That's right. That's right. We have a lot of quirks and flaws in our brains, and some of these will really keep you up at night too. So, for example, we are not evolved to do math, to do much math anyway, computation. We don't have a concept of numbers, really. What we do have a concept of is relative comparisons. And this leads to some very strange consequences. So, and these are called cognitive biases, by the way. And cognitive biases are errors in our thinking that are not just limitations or you make a mistake once. It's an error that you'll make over and over and over again, and that all people have in common. So what are some of these cognitive biases? So for example, and marketing and advertising, they know this, they've long figured this out. But if there's a certain bottle of wine in the wine store and it's marked at $15, and it's just not moving, the best way to get that bottle of wine to move is to put a sticker above it that says $25 and then an X through it. and then it's still $15. It's the same wine, and it will fly off the shelf. And every time you go into shop, notice how often the price is listed as a markdown. It's always marked down, except in very high-end stores where people like to show off how much they're spending on things, which is another error we could talk about, for advertising and signaling their wealth. But pretty much every store you walk into, almost everything is marked down at least some degree. And it was never full price. They were never going to sell those jeans for $100. They always were going to sell them for $70, but they want you to think that they're worth $100. And the reason why that works for us is because we measure value in comparative terms only. $70 is less than 100, and so we think we're getting a good deal. And this really, you can scale this up into all kinds of economic problems that we have as a nation, and as you're managing your household finances. These are a lot of errors. And in fact, evolutionary theory is having a big impact in economics and the field of economics as people understand why humans behave this way when it comes to money. Other problems. So we are prone to memory problems, memory errors, and encoding our memory in ways that are very defensive, biologically defensive for us. So they probably served us well in the past by editing our memories, but now it certainly causes problems. What are some of the other evolutionary problems with our brains? I mentioned before racism and xenophobia. Those are definitely side effects of evolution, and have negative consequences. I think more than anything else, the most critical problem in our thinking is that evolution has never rewarded planning ahead very much, more than a generation, if that. Evolution has never rewarded self-control and discipline and moderation, right? Evolution is always it rewards short-term gains. And if you look around the world today, almost all of the major problems we're facing are of our own doing, right? We're not facing an asteroid. We're not facing, I mean, if you can think of how the world, humanity could collapse, it's almost all because of our own mistakes, our inability to manage resources, for example. We could easily be done with fossil fuels. The second we realized that the burning of carbon was going to lead to warming of the planet and therefore making our lives tougher, we could have very easily switched to renewables, renewable carbon, so that way it's carbon neutral, or just alternative modes of fuel. All the technology is there. We are not waiting on the science. We could switch immediately if we want to, but there are people who get very wealthy with the system as it is now, and so we're not. We have the ability to fix this, but we choose not to. And there's always a reason that we find to not to. Why? Because you have to have some short-term sacrifice for a long-term gain, and evolution has never rewarded a species for short-term sacrifices and long-term gains. It's just not how it works. And so our limited ability to plan ahead is, probably the biggest error we have right now, the one that's the most crippling to our success. If you were to tell me 100 years from now we're going to suffer an apocalyptic scenario, I would bet everything I have that it's a problem of our own making.
Mm-hmm. But because we have these cognitive biases, cognitive errors, should we say that we are irrational because we tend to think of ourselves as rational beings, or can we still say that we are rational but with some caveats?
That's an interesting question. I think that's more philosophical than I tend to think of of this, because rational, and this is a big concept in evolutionary economics, the rational actor, the idea that everyone really is acting in his or her own best interests, and we just have to decipher that. I tend not to think that way, because our own best interest, what does that mean? That in and of itself is such a complex philosophical idea. So for example, I have 2 children, but they're adopted. They're not my biological children, but yet I love them and care for them, and the same way a birth parent would, and so on and so forth. Does that mean I'm being irrational? I suppose there are parenting programs in my brain that got activated once I started caring for these youngsters. But I don't care. It doesn't bother me one bit. I don't think of myself as being irrational. If anything, I know that there are plenty of people on the earth. I didn't need to make more. We're not running out. And there were children that need homes, so it was a logical choice for us to make. That seems rational to me. especially if you're considering long term. I don't care about my genes, but I do care about suffering of other individuals. Does that make me irrational? I don't know. I just don't. I don't find that kind of logic satisfying. Are we rational? No, humans definitely are driven by emotions. What we have learned to do is to rationalize our emotions. I do think, though, that we become more rational, more logical, and more wise when we make decisions together communally rather than as individuals. And this gets into politics. And so a lot of people on the political right, freak out when they hear me say that I think we make some decisions better together than we do on our own. But I think there's just so much evidence for it. Perfect example, this is a classic study that was done with hockey players in the 1980s, I think. A new kind of helmet was invented that reduced head injuries in hockey players by like 90%. It was a very good protective helmet. And it was legal to use, but it did inhibit their peripheral vision a little bit. No hockey players would use it. Even though it made them safer, it gave them a disadvantage. However, when they were taking a secret ballot election to choose to mandate that helmet, it won enormously. So together, the hockey players realized if we all are wearing the helmet, we're safer and nobody gets an advantage or disadvantage by the loss of peripheral vision. But if they had to make that decision as individuals, they wouldn't do it. And it's the same thing with these big, huge SUVs. People drive them because they want to be safer in this big, huge tank. But it's only because everybody else is in those big, huge tanks that you even have that problem to begin with. So we do make some decisions better together. We are wiser and more logical and more rational when we make decisions together, when we recognize how interconnected we are. And we just think better that way. We are a communal species. We are a social species. And I think it's time that we stop fighting that and recognizing the advantages of it, rather than this rugged individualism of doing it all on your own. Rather than tying our fates together, we make better decisions and to be happier and healthier, I think.
Mm-hmm. So I think that I haven't tested you yet about this, but do we need these errors we've been talking about to function properly, or could we do well without them?
Again, it's a mixed bag. So the way that our vertebral column is built, straightening out the backbone is not a solution. We would be worse there because there's nothing. We use that in which to hinge and connect our internal organs, especially for women and the gynecological organs really need that scaffolding. So we can't fix that one, or we can't straighten the backbone. But there are other ways that we can fix it. Right? We could, for example, change the way that the discs intercalate into the vertebral column, because they still fit there as if we were walking on all fours, and that's why they slip forward, because gravity is now pulling them in a different direction than they were designed to. Some of the errors, it's good that we have them overall, but most of them it would be now that we do have a brain that's not limited to mutations. We can think more creatively. If we could think of a way to make the ACL bigger and stronger, that would be great for all of us. If we could think of a way to prevent all the attachments in the ankles, we eliminate some of that redundancy in the ankle, that would be great. But by and large, I think most of our errors, we're sort of stuck with them the way that we are. But knowing about them helps you live in better harmony. I think that's more of the lesson, is to understand what our limitations are and why they got that way, and live in better harmony with our bodies and with our minds and with each other. So sibling rivalry is a great example too. I love this as an error in our biology. So many people have this experience of where we tease each other, we compete with each other for parental affection. I'm talking about our siblings. But yet, if anybody from outside of the family were to pick on one of your siblings, you would go in and defend, right? So you have this ability to both compete and cooperate, and it can flip just like that. I mean, my older brother used to tease me relentlessly, but if any of his friends did, he would stop them, instantly. And so but recognizing that we are competing for our parents' affection, for example, that's the primal drive, sort of disarms it. And so when we have some of these instincts of, oh, my parents are always better to my siblings, if we sort of recognize where that comes from, you can talk yourself out of it. Maybe not out of the first reaction, but you can take a breath and realize, okay, well, we're in an evolutionary conflict right now. I can choose to move past that. So even though I do think evolution shaped us the way we are, it doesn't mean that that's our fate. I'm not fatalistic about it. Once we know these things, we can sort of rise above our past. And I think that's really the challenge for our species, to see if we will rise above our lowly origins.
So earlier we've talked about how we are still evolving, but could you tell us about some of the sources of evidence for that? I mean, are there any specific traits that people are seeing evolving in real time, for example?
For biological evolution, there's not a lot of those around, but there are some. A classic example was done by the population of New Guinea, who was one of the largest land masses of uncontacted peoples. The uncontacted tribes in New Guinea were really just contacted for the first time in the 19th century. And what we found is that, as predicted, they developed type 2 diabetes very quickly once they had contact with Westerners, and their diet immediately switched in the same generation from very low in carbohydrates to very high in carbohydrates. Obesity and type 2 diabetes developed in them very quickly, and also some of the particulars of how the food got to them, et cetera. And before any of this was figured out or known, or we knew how to treat it, they had a lot of death from these causes that actually impacted the genetics of the population. So the population started to have natural selection acting against the forces that create type 2 diabetes. So it's interesting. And there was measurable differences in some of the frequencies of certain versions of genes. Now, we've largely stopped that because we can manage diet and type 2 diabetes in the physiology. That's one of the few examples I know of biological evolution in action for us to see and observe in real time. But there's other, a little more distant but interesting examples. So the one that I think is most interesting is the ability to drink milk beyond weaning, beyond adolescence. So all humans are able to digest lactose, which is the sugar, the disaccharide that's found in milk, as infants. Every human is born with the ability to drink milk originally, pretty much. But most humans, outside of a few groups, Europeans the largest of those groups, most individuals in the human population grow out of their ability to digest lactose and become lactose intolerant after they wean. So after they stop intaking lactose, if you don't have lactose for long enough, you lose your ability to digest it, except in certain populations, Europeans being one of them. And that we now know the genetics of this. And this has not evolved once, but several times in human populations. So there's a tribe of the Hadza people in Africa who have also evolved the ability to drink milk late in life because they, rather than farming, they are pastoralists, right? So they have, in their case, goats and sheep that they drink milk from later in life. And you've got to remember that milk is an incredible resource from livestock. Because it's portable. It's a portable source of nutritious, very rich, nutritious food, and also clean water. Just the fact that it's clean water is a great thing about milk. And so this ability, this adaptation, had so much advantage to it that it popped up in the population multiple times. And we now understand the genetics of it. And the European milk drinking mutation is different than the African milk drinking mutation, and there have been a couple of others in South America and in Southern Asia as well. But most populations, that mutation never made it because there wasn't a steady source of milk around anyway. What's interesting is that we did not domesticate cows for the purpose of milk. And in fact, we didn't even start using milk as milk. We used it for cheese and yogurt. And the reason why is cheese and yogurt don't have much lactose in them. Because through the process of the aging, of the fermentation that goes on, the lactose is converted. And so most people who are lactose intolerant do just fine with cheese and yogurt because the lactose has already been digested for them by the bacteria. But I just think that's one of the few but really well understood examples of biological evolution in action, responding to the advantages and disadvantages of those mutations.
Mm-hmm. If we wanted, could we eliminate artificially some of these errors, and would that be a good thing?
Yeah, I think some of the genetic errors that we have, we can and we will eliminate. And anything that's caused by a single gene, I think is within reach of fixing, including lactose intolerance. Actually, it would be very easy to fix. However, it's not a huge medical problem, so I don't think that'll be first on the list. But I think we're very close to curing, cystic fibrosis permanently, and hemophilia and others. Sickle cell anemia would be a very, very good one to do early. Um, Other kinds of errors are not so simple because most of our traits are controlled by lots and lots of different genes. And one example I use is height. So human height, we know, is affected by about 800 different genes. We also know that there are many more genes that we just don't know. So the heritability of height is even more than those 800 genes, possibly 3 times more. So definitely over 1,000 genes affect human height. So, and all of those genes do other things too, right? None of those are only height. They do lots of other things. So our ability to tweak the genetics of height is so far out of reach, because there would be so many different consequences. And that's the real danger. It's one thing to fix the cystic fibrosis mutation, because it did begin as a mutation. There's a functioning version of a gene and a less than functioning version of the gene, and we just simply convert it back, and we'll do that. That'll be fine. But tweaking other of our traits genetically is really fraught with danger. I mean, there's almost no genes that you can just tweak at will without negative consequences that were unintended and unknowable at the time. So let me give you an example, and here's the danger. In the United States in the 1940s and 50s, a group of farmers decided they wanted to raise bigger chickens to get more money from their investment. Why don't we raise bigger chickens? And we can just do this through regular breeding. We don't have to do genetic engineering. We just pick the biggest and biggest chickens, and we'll mate them with each other, and we'll have different farmers doing it, and we'll exchange the big ones so that we don't get too much inbreeding. This was what they did, and it worked for a little bit. So for a while, the chickens were getting bigger and their yields were going up. But then within a few more generations, they realized their yields started going down and down and down and down, even though the individual chickens were getting bigger and bigger and bigger. Why were their yields going down? Well, by selecting for height, they also accidentally selected for aggression. And these chickens were pecking each other to death. And they were literally killing each other. And so their yields were going down because the chickens became horribly antisocial. So imagine if we wanted to select humans that were taller, because for whatever reason, and we ended up with this race of nasty, aggressive, tyrants. So that's the thing. We don't know what you're going to accidentally select for if you start screwing around with something as simple as height. Even something as simple as intelligence, which is much more complex than height, genetically speaking. Think of the dangers of what you could accidentally select for also. So I don't think we're anywhere near doing the designer baby anyway, but hopefully we all have better sense than that, to realize from the lessons of our past that you never know what you're going to bring along for the ride in terms of other traits. So why don't we just avoid that? And instead, fixing simple genetic diseases, that's the way to go, and we can just leave it at that. But by the way, we've now solved the problem of these chickens. What do? Is we put them all in individual cages, right? So chickens in the United States, most of them are raised in these tiny cages that are barely big enough for the body of the chicken so that they can't peck themselves and each other to death. That's how we've solved it. It's by being cruel and inhumane. But that was, and now the chickens have gotten bigger and bigger and bigger because we stopped them from being able to kill each other.
But there in your answer, you focused a lot on genetic engineering. Couldn't we arrive there, I mean, in trying to solve some of these problems through human enhancement? I mean, as the transhumanists say or propose,
Right.
could become, for example, cyborgs or something like
Right.
that.
I think some level of that is inevitable, and this began a long time ago. We started using canes and crutches and eyeglasses, and so we've been using technology to enhance our experience of the world for a very long time. And I think that will continue. I think it'll get more sophisticated. Um, I don't know that we're going to implant electric devices in our brains anytime soon, but the idea that we could sort of take over from our limited physiology, you could think of a hearing aid, but a much enhanced hearing aid, or extended vision, binocular vision, that could be piped directly into your optic nerve. I don't think that is fraught with too much danger as long as we go slowly with that kind of technology. I mean, we have pacemakers now, right? We have the ability to detect an irregular heart rhythm and correct it when necessary with a device. So we're already doing that, and I think that we'll continue to do that. Whether that leads to a truly transhumanist experience where we're sort of transcending the limitations of the body altogether, I'm not so sure about that. And the idea that we would upload our memories to that, I just think that's so far out from anything close to what we have right now that it's really not worth our time to think too much about. What I would like to do is to solve the cruelest of diseases and fix them, and extend lifespan of healthy lifespan when you have full control of your faculties and so on and so forth. And I think we're doing that. But if you notice that modern medicine has largely solved infant mortality, and it's added maybe 10 years to the end of the life, but that's about it, right? But what it has helped with is that you live a richer, fuller life for a longer period of time. And I'd like to see us concentrate on that rather than just simply living longer.
Mhm. Do you think that we will ever be able to live forever, and would that be a good thing? And of course, I'm not trying to ask you a philosophical question here, because we could talk from an existential perspective if it would be good or bad for people to live forever. But biologically speaking, could it bring some new problems?
Right. I think that uh, longevity has always been the opposite of adaptability and resilience for a species, because the longer lived an individual is, the slower that species is to adapt to new challenges. So there's this great tendency in life where you get bigger and bigger bodies and longer lifespans and extinction, and then bigger and bigger bodies, longer lifespan, extinction. And that's generally how it goes, because again, short-term gains at the sacrifice of long-term consequences. And so generally, the longer you live, the less adaptable the species is to changes in an uncertain future. Now, I assume that we're talking here about humans and how we've escaped natural selection largely anyway. Do I think it would be good biologically that we would live forever or indefinitely? The answer is no, I don't, and I can't really see that it's going to happen anytime soon anyway. I think it would just change our relationship to each other and to the world and to resources and everything so much that we would be unrecognizable to how we live now. The idea that our life is temporary and finite is a big part of how we structure our lives and our relationships. And that is important for our biology as well. We're not designed to live forever. Aging is a programmed process. It is not just a natural breakdown. Yes, there's a natural breakdown, but our body is very good at repairing itself. But it is designed to have a lifespan, to make way for new generations. And if there was some advantage in just one generation living forever, then biology would have come up with that. But long term, that is a bad recipe for success. And I think if you map that as a metaphor onto our existence now, I think it holds. It is a bad recipe for success that the individuals live forever.
Mhm. Okay, so one last question. We've been talking about the errors. What about the good, positive traits that humans have? What are some of the ways humans are better than other animals?
Oh, that's a great question. So I think there are. I'm thinking about the two that I'm the most thinking about lately. So for one thing, we have in our frontal cortex, our neocortex up in the front, we have what's called executive function, which is the ability to restrain our impulses and not act on emotion and impulse immediately, but to deliberate and make more thoughtful decisions, okay? Impulse control, self-control, whatever you want to call it. And what it has allowed us to do is to restrain what we call reactive aggression. So we don't react necessarily with violence as often as other animals do. And I know that seems weird to say that we're not a violent species. We are a violent species, but that is proactive aggression. So that's a planned predatory attack. We do that better than anyone, but we don't have reactive aggression. We're much more, we're less driven on instinct and more driven on deliberative decision making. And we forget that. And I think we need to remember it and to be less reactive and less impulsive and to engage our executive function to make decisions. So that's one advantage we have that I'd like to see us remember and concentrate on. The second one is we have what's called tolerance of strangers. And so in most species, and I'll just take our closest relatives as an example, chimpanzees. If you take a chimpanzee out of his group and bring him into a different part of Africa and introduce him to another group, he will be killed immediately. Strangers are not tolerated in most social species. You have a group, and then you have other nearby groups which have a little bit of sort of cautious familiarity, but with occasionally erupting in violence. But if there's zero familiarity, there is some degree of territoriality in basically almost all mammals. Interestingly, you find this tolerance of strangers in other species as well outside of the mammals, but that's a topic for another day. So what we have is tolerance of strangers, but that tolerance of strangers only works best when you recognize them in some way. You don't have to and we've moved beyond recognizing them as an individual, but rather recognizing them as a member of a group. And so, for example, you can walk into a cafe and not know anyone there and still not be subjected to violent reaction, right? But why? Because they recognize you. You belong there. However, the less recognizable you are, the more there is in terms of that reactive aggression. So you walk into a cafe in your home country, you're fine. But if someone from a faraway land, dressed in different ways, looking different ways, speaking a different way, walks into a cafe, they might not be immediately reactive with violence, but there's suspicion and there's that otherness that's being concentrated on. So I think our tolerance of strangers is something that we can capitalize on and expand, and we can break down the cultural barriers so that we don't see other people as strangers. And that's an ability we have that we can engage. And I would mention that way at the beginning of the interview. We can engage that more than we do. If we didn't have that structure to begin with, tolerance of strangers, then I don't think we would have had a globalized society at all. We would have been too reactively aggressive. However, we can tap into that tolerance of strangers by recognizing what it is that makes people familiar, what it is that makes them predictable, what it is that makes them recognizable as non-threatening, and then try to expand that in how we raise our children and how we talk about different cultures. And rather than focusing on differences, we focus on commonalities. There was a study that was done that took different kinds of people. It was a lot of like Americans and Middle Eastern Muslims, and put them in a room and just stare into each other's eyes for 30 seconds. And after that, both parties were radically different just from staring at each other for 30 seconds and not saying a word. Because what that allows you to do is to see past the things that you notice immediately: skin tone, dress, language. See past all of that and see their humanity. You see back to all the things that you have in common. So we have that program, that ability to recognize members of our group that we could choose to capitalize on more. So those are the two areas of human nature that we really don't find in other creatures that we could, I think, expand on: executive function and impulse control, reduction of reactive aggression, and the ability to recognize individuals that are strangers but otherwise part of our group. So if we could engage those more, we might have a better, more peaceful future.
Mm-hmm. Great. So just before we go, would you like to mention some places on the internet where people can find your work?
Sure. I'm on Twitter, so Nathan Lents is my Twitter handle, just Nathan Lents. I also run a blog called the Human Evolution blog. I don't post there as much as I should, but I'm hoping to get back into it. People don't read blogs as much anymore, but the Human Evolution blog, Twitter, those are the best ways to find me. I mean, you can also look up my email. I tend to respond to most email that's kind and friendly. As someone who talks about evolution, I sometimes get unkind emails as well, and I tend not to respond to those. But yeah, I'm on Twitter, I'm on Facebook. So if you could just Google Nathan Lents. Fortunately, it's not a common name, so I'm pretty much the only one out there. And I'd love to interact with people from all over the world. So drop me a note.
Okay, great. So I will include all of that in the description box of the interview. And Dr. Lentz, thank you a lot for coming on the show, and it was really fun to talk to you.
Oh, Ricardo, you were a great interview. I enjoyed this very much.
Hello everybody, thank you for watching this interview until the end. As you might have noticed, I've been doing this channel for 3 years, bringing you top academics and intellectuals from a variety of fields. And I would like to ask you to please visit my Patreon page and to consider making a pledge there. Even $1 would already be a great help. Otherwise, you also have links to PayPal in the description box of the interview. And please share it, leave a like, and hit the subscription button if you liked the interview. I would also like to give a huge thank you to my main patrons and PayPal supporters, Karen Litske, Anne Blanchett, Perelga Larsen, Lau Guerrero, Francis Ford, Hans Frederick Sunda, Ricardo Vladimiro, Craig Healy, Adam Kessel, Olaf Alex, Jonathan Wiesel, Anjan Kata, Jacob Klinkby, Matthew Whittingbird, Arno Wolf, Tim Hollesy, Enrique Lenius, John Connors, Paulina Barron, Philip Force Connolly, Jerry Mueller, Herbert Gintis, Rutger Voss, Bo Weingard, Rebecca Newberger Goldstein, Dan Demetriou, Robert Windager, Rui Inácio, Arthur Coe, Zoop, Marco Neves, Colin Holbrook, Susan Pinker, Thomas Trumbull, Bernardo Seixas, Pablo Santurbano, Simon Columbus, Jorge Spinha, Phil Kavanagh, Corey Clark, Mark Blythe, Roberto Inguanzo, Mikkel Stormir, Eric Neumann, Samuel Andreev, Tiago Nunes, Bernard Hugney, Alexander Dunbauer, Omri Hickson, Fergal Cusson, Evan Bodrenko, Hal Herzog, Nuno Machado, Don Ross, João Alves da Silva, Jonathan Librant, Oslam Bulut, Nathan Nguyen, Staten T, Samuel Correa, Eric Hines, Mark Smith, J.W., João Eira, Tom Hummel, David Sloan Wilson, Yacila Deza Araújo, Eden Solon, Romain Roach, Dmitry Grigoriev, Diego Londoño Correa, Tom Roth, Yannick Punter, Adaner Usmani, my producers Izar Webb, Jim Frank, Lucas Stafiniak, Ian Gilligan, Sergio Quadriano, Luís Caetano, Matthew Lavender, Tom Van Egdam, Curtis Dixon, João Linhares, Benedict Mueller, Vega Guidi, Sardas France, and Niruban Balachandran, and my executive producers Michel Ruzieski, Rosie, and James Pratt. Thank you for all.